Adhesives are seeing extensive use in the space sector in place of mechanical fasteners such as rivets and welds. Adhesive bonds offer superior stress distribution across joints, allowing for stiffer structures and lighter materials. They also help join materials with different properties such as aluminium to carbon fibre. With design and surface preparation, these bonds rival the strength and longevity of conventional rivets and welds. Standard adhesive practice in the space industry involves using a wet chemical surface treatment process, which often includes chromates and other hazardous materials. Chromates are a toxic substance used in coatings that are carcinogenic when inhaled, ingested, and through contact. The European Chemical Agency has deemed this a substance of very high concern, and the disposal of the hazardous waste from these chemical baths is an expensive and strictly regulated process. The European Union is currently implementing REACH regulations to restrict the use of these chemicals. Chromates have proven to be very harmful to human health. They are carcinogenic, mutagenic, and are highly irritating for plants and animal tissues even in small doses. Chromate's high water solubility also allows it to pass through the cell membrane where it can damage DNA. The solution is osmosis, a one-step modification of space integrated surfaces. This process uses our unique co-blast method to cleanly and safely deposit a robust surface ready to bond with excellent adhesion properties. Enbio's solution involves using its co-blast coating technology in a one-step, environmentally friendly, dry process that does not rely on these hazardous chemicals. Many chromate alternatives do not adhere properly to the substrates consistently, or their application is limited to simple geometries. The alternatives that do perform adequately usually require sensitive processing steps, or still do not meet the performance results of their chromate counterparts. Not only does co-blast remove the need for hazardous chemicals, it also reduces the surface treatment to a simple one-stage process that will reduce cycle time and the required factory floor space. Enbio has already been qualified for use in space and has solved a mission-critical problem for the European Space Agency. Enbio is now modifying this process to solve another significant problem for the space sector in a clean, green, high-performance solution. Co-blast uses conventional blasting equipment to remove a metal's natural oxide layer and replace it with a desired functional coating. Abrasive and coating powders are simultaneously blasted onto the metal's surface. The abrasive mechanically abrades the substrate, exposing active chemical bonds to which the coating particles adhere before an oxide layer can reform. The level of coating substrate integration achieved by this process is far beyond most coating methods. Enbio's co-blast process is capable of beating the next best in class with a range of coatings. Co-blast surfaces also exhibit a vastly longer shelf life than current adhesive primers. Many commonly used priming systems require parts to be bonded within hours or days. However, co-blast has a much longer shelf life and can be bonded weeks or months after priming without losing adhesive performance. This graph shows the effectiveness of co-blast versus an aerospace adhesive primer. While the untreated bare metal relies on chemical bonds between metal and adhesive molecules, the co-blast treated surfaces offer a more compatible surface for bonding to occur. Compared to the standard process, co-blast has more bonding power in terms of shear strength as a primer, while at the same time being a cleaner alternative. Co-blast has multiple applications besides adhesive priming, including thermal control and mold release. These areas consist of large global markets with significant coating challenges across industries. While aerospace is a significant user of acids and toxic chemicals for coating, the automotive industry, oil and gas, and many more will be deeply affected by REACH's prohibitions and will considerably benefit from co-blast's innovative green process without having to sacrifice performance. Enbio's aim is to eliminate these harmful wet chemical processes and replace them with a clean, chromate-free, one-step surface modification process called co-blast. The key goal of this 2-year project is to bring a viable chromate-free adhesive primer to the European space sector market. Our objectives include promoting Coblast as a green alternative, connecting with international space agencies and organisations, creating a new industry standard around environmental sustainability, identifying and penetrating other industries with similar hazardous wet chemical practices beyond aerospace, realising other functions and applications of Coblast, research and develop coating and coating processes, increasing levels of performance and resistant properties.